Okay, so question 9. We're going to solve this initial value problem by using Laplace transforms. I have y prime minus y is equal to t times e to the 2t, and y of 0 is equal to 1. So you want to start by applying the Laplace transform to each term. Here's my tables of transforms. I'm going to apply the Laplace transform to each term. Notice I've got the Laplace of y prime, it's here, the Laplace of y, the Laplace of t e to the 2t, that's going to be our first shifting theorem, and also the Laplace of t. So we'll start with the Laplace of y prime is s times y minus y of 0. And then the Laplace of y is just y. And the Laplace of t e to the 2t is this first shifting theorem. It's going to give me the Laplace of t where s is shifted to s minus 2. And the Laplace of t is 1 over s squared. And again, the s is going to shift to s minus 2. So I get 1 over s minus 2 squared. So my initial condition says y of 0 is 1. Replace y of 0 with 1. And when you solve an initial value problem using Laplace transforms, the goal is to convert the equation from a differential equation to an algebraic one, which we did. We've gotten rid of all of the derivatives so that we could solve it. We're going to solve for y by bringing the 1 over to the right side. Now, if I wanted to, I could combine these two fractions, but because I know I have a shift here, I think I'm going to leave them separated, and then divide by s minus 1. So I have to divide each one of these by s minus 1. And then once it's solved for y, when you apply the inverse transform, you get the answer to the equation. And this is where most of the work typically comes in, rewriting these fractions so that you can apply the inverse Laplace transform. So with this first fraction, I'm going to have to do partial fraction decomposition. So I'll do that on the next page. There we go. Partial fraction decomposition. When I take the first fraction, I can break it up into a over s minus 2 plus b over s minus 2 squared, and then plus c over s minus 1. Multiply through by the common denominator, and you get a times s minus 2 times s minus 1 plus b times s minus 1 plus c times s minus 2 squared. And here, rather than expanding everything out and combining like terms, I'm going to use arbitrary values of s to simplify this to be able to solve for a, b, and c. So if I let s equal 1, then notice that any of these terms that have an s minus 1 factor will cancel out. And it'll leave me with, here if s is 1, 1 take away 2 is negative 1 squared times c is equal to 1. Negative 1 squared is 1, so that tells you c is equal to 1. So next I'm going to cancel out this s minus 2 factor by letting s equal 2. So the a term will drop out, the c term will drop out, and on the second term, when s is 2, 2 take away 1 is 1, so it gives me b is equal to 1. and then choose any other value to solve for a. I chose 0, and when s is 0, I get negative 2 times negative 1 is 2 times a, b is 1, and 0 minus 1 is negative 1, so this becomes negative 1. C is 1, and 0 minus 2 is negative 2. Negative 2 squared is 4, so that's plus 4. We get 1 is equal to a times 2 minus 1 plus 4. Negative 1 plus 4 is 3, so subtract 3 to get 1 minus 3 is negative 2, is 2a, and then divide by 2, and you get a is negative 1. So here I get a is negative 1, b is 1, c is 1. And we'll bring that back so that we can solve the equation right here. Negative 1, 1, and 1. Okay, so this is what we had. On the first fraction with partial fraction decomposition, we showed that the first fraction was equal to negative 1 over s minus 2 plus 1 over s minus 2 squared plus 1 over s minus 1. And then my second fraction, 1 over s minus 1. Notice that these can be combined to give you 2 over s minus 1. And then applying the inverse transform to each term, the inverse Laplace transform of y is y of t. The inverse transform of 1 over s minus 2 is e to the 2t. The inverse transform of 1 over s minus 2 squared, that's going to give you a shift. It's going to give you e to the 2t times the inverse transform of 1 over s squared. And the inverse transform of 2 over s minus 1 is 2e to the t. Again, using this Laplace of e to the at is 1 over s minus a. So again, inverse transform of 1 over s squared is t. And that's our answer. Y of t equals negative e to the 2t plus t e to the 2t plus 2 e to the t.